So back to our classification, strabismus, as we mentioned earlier, could be false or true. The first type of true strabismus is the latent strabismus or the heterophoria, which is a hidden form of strabismus. Latent strabismus or heterophoria. By definition, it's a state of muscle imbalance in which there is tendency for eye deviation, but this tendency is tracked by the brain for the interest of binocular single vision. So a state of muscle imbalance means strabismus, in which there is tendency for eye deviation. The eye wants to deviate but does not deviate. Why? Because this tendency is checked or prevented by the brain for the interest or the sake of binocular single vision. The brain wants to fuse the two images of the two eyes and have one single image, which is binocular single vision. And for the sake of that, the brain maintains muscle balance and controls the latent strabismus and prevents its appearance and turning into manifest strabismus. So it's a state of muscle imbalance in which there is tendency for eye deviation, but this tendency is checked or prevented by the brain for the interest or the sake of binocular single vision to avoid diplopia. Etiology of heterophoria. The etiology of heterophoria is errors of refraction, uncorrected errors of refraction. Hypermetropia causes esophoria. How? The hypermetropic eye has a small axial length or a short globe. So the image is focused behind the retina. In order to focus the image on the retina, the lens has to undergo accommodation by contraction of the ciliary muscle. And there is a triad of accommodation, meiosis, and convergence. So too much accommodation means too much convergence, which in turn turns into esophoria. So hypermetropes develop esophoria if uncorrected by glasses. On the other hand, myopes develop exophoria if uncorrected by glasses. How? The myopic eye has a big axial length. It's a large globe. Myopic patients focus the image on their far point without accommodation. For example, a myope of -3 has a far point of 100/3, so the far point is 30 centimeters. A myope of -5 has a far point of 20 centimeters. A myope of -4, for example, has a far point of 25 centimeters. So if the object lies at 20 or 25 or 30 centimeters, the myope will focus the object at his far point without any accommodation. So the object is focused without accommodation. No accommodation means no convergence, and in turn, exophoria. So uncorrected myopia leads to exophoria. So the cause of heterophoria is errors of refraction. Uncorrected hypermetropia results in esophoria, and uncorrected myopia results in exophoria. Symptoms of heterophoria. At the end of the day, when the patient is very tired after prolonged work, the patient will start complaining of eye strain or muscular athenopia, which is tiredness and pain related to the eye muscles due to exhaustion of the eye muscles, because the patient has been trying to control his strabismus all day, and at the end he gets tired. After that, the patient intermittently fails to correct his strabismus. So there is strabismus and then straight eyes, strabismus and orthophoria, heterophoria and orthophoria. What happens during periods of heterophoria, or when the strabismus becomes manifest for a short period of time, there is diplopia. Then, when the patient corrects this strabismus, he sees one single image again, so no diplopia. Diplopia, no diplopia. Diplopia, no diplopia. The patient describes this as running of letters together during reading. Eventually, the patient cannot maintain control on his eyes anymore, and heterophoria turns into manifest strabismus or heterotropia. And at this point, the patient complains of diplopia, and this happens after very prolonged work. How to diagnose heterophoria? If the patient comes into the clinic with straight eyes, but he has these complaints, how can we tell if he has heterophoria or not? The principle is to abolish fusion by dissociating the two eyes. As we mentioned earlier, that the heterophoria is prevented from becoming manifest by the brain in order to achieve binocular single vision. So if there is no binocular single vision, the brain will not control the eye balance anymore. How to do that? By abolishing fusion. How to abolish fusion? By cover tests or by other tests. If we cover one eye, there's only one image. There are no more binocular single vision. So the brain will not maintain control over the muscle balance anymore, and the eye will deviate under the cover. And we diagnose heterophoria. Or we can use other tests. For example, the Maddox-Art test or the Word-for dot test, where we present different images for each eye. So if the images are different, they cannot be fused, and heterophoria becomes obvious. Cover test to diagnose heterophoria. In the upper picture, both eyes are fixating. Then we cover one eye. If the eye does not deviate under the cover, this is orthophoria. That is no latent strabismus, no strabismus at all. If the eye deviates inwards under the cover, there is esophoria. If the eye deviates outwards under the cover, there is exophoria. And we'll repeat the test for each eye. So this girl has straight eyes, and when we cover one eye with a transparent occluder where the patient does not see, but we can see her eye, we see there is exo deviation under the cover. So she has exophoria that only appears under the cover. Treatment of heterophoria, as the cause is errors of refraction, so the treatment is to correct the errors of refraction. We perform cycloplegic refraction and give the proper glasses. So we talked about apparent or pseudostrabismus, and true strabismus we talked about latent strabismus or heterophoria. The next step is to talk about manifest strabismus or heterotropia.